Okay, welcome to another Simple Engineering Snippet. In this instructional video, we will be reviewing how to calculate the moment for a single force or the resultant force from a group of forces that are all contained in the XY plane. I hope you find it useful. Okay, so if we have a single force or a system of forces that all lie in the XY plane, then we know that the resulting moment is going to be in the direction of the z-axis, either plus direction or minus direction. And the magnitude of the moment of the force is going to be equal to the magnitude of the force times the distance d, where d is the perpendicular distance from the axis at point of the moment to the line of action of the force. What this exactly means hopefully will become more evident as we work through some examples. And we can use the right-hand rule to determine the actual direction, whether it's in the plus or minus direction of the z-axis. And again, hopefully all this will be evident when we work through examples. Let's review a right-hand coordinate system, which is the basis of using the right-hand rule to determine the resulting direction of the moment. And so we have the XY axis. If I take the palm of my hand and point my fingers in the positive X direction and curl them towards the Y axis, then my thumb is pointing in the positive Z axis. And we're going to see a similar type of procedure to determine the direction of the corresponding moment. So here is a very simple example where we have 100 Newton force. It's acting at a distance of 2 meters from the point O, and we want to calculate the moment. And just from a physical point of view, we can see that it's going to be putting a torque in the clockwise direction. And so I would put the base of my palm at the origin 0 where I'm taking a moment, point my fingers in the direction of the force, and then curl them in the direction of the force. And yes, we see that we get a clockwise direction for this moment, and my thumb is pointing into the screen, and so that moment is negative. It's pointing in the minus z-axis. And so to calculate the moment, it's just the magnitude of the force times the line of the action of the force and the point where you're taking the moment. In this case, that's just 2 meters. And so we get 200 Newton meters. Sometimes you might note that with the actual curl direction, but you could also put the minus sign, and that would be correct. Okay, so here's the next system. Again, we're taking the moment about point 0, and we have a force of 50 newtons acting at 0.75 meters beneath point 0. And so we need to determine the line of action, so extending this over. And so, yeah, the distance d that we're going to be using in a moment is going to be 0.75 meters. So in reality, the 2 meters in this case really does not come into play. And so, again, the direction with my right-hand rule is going to result in a twisting moment in the clockwise direction. If I use the right-hand rule of thumb, my thumb will be pointing into the screen. So again, this is going to be negative. And doing the arithmetic, I get that the corresponding moment is 37.5 Newton meters. And again, I can specify that with a negative sign because by definition it's either in the positive z direction or the negative z direction. Okay, working through one more example. This looks a little bit more complex, but in reality it's not. Once again, we have a 40 Newton force acting at the end of this member, and we need to determine the line of action, the perpendicular line of action between the point of the moment, which is point 0, and the line of action of the force. And in this case, that is going to be equal to 4 meters plus, using a little bit of trigonometry, 2 times cosine 30 degrees. And once again, this is going to be in the negative z-axis direction. And so now all we have to do is do the arithmetic. And we get that the resulting force is 229 Newton meters clockwise or in the minus z direction. So I hope this was a useful video, and please like and subscribe, and have a great day.